all the stuff we make is designed on CAD, so we use Crux or SolidWorks, so you model the complete product right at the start. As you go through the design process, you need to know how you're going to manufacture it as well. So just picking this part here, which comes off the road legal snackers, you'll know that you need a certain offset or certain angles, and then you design it around, say, the tooling you've already got or the tooling you can get and the capabilities you've got, so you can produce it, you know, yourself or in-house accurately and effectively. Because we laser cut it, which I can show you in a minute, we laser cut all of our steel work and then fold it.
So that's on this machine over here.
So that's the laser cutter there.
Okay.
It allows us to prototype parts easily and then develop, you know, once we've got a finished part, produce it accurately and efficiently every time.
So after it's been laser cut, then it comes over to this machine, James?
Yeah, so it goes over to this one for folding. Such as these parts here, which are all to work in the system. So this will be a flat blank effectively. So that's how it comes off the laser machine. So it's all cut, nicely finished. And then you use the press brake. So by putting this part in here against the back stops, which, you know, depending on how you set them up, the tooling comes down and then folds it to give you the finished product, or the finished part. Right, so this is the tooling we use on folding the various types of steel. Depending on the grade and the radius you're after and the intricacy of the folding, you've got all, you know, different sorts of tooling here. Very expensive stuff. This cart here with all the tooling, about £25,000 worth of tooling. Right, so this is the laser cutter that we use to cut the flat planks, which I showed you previously. So we just use a light beam to cut the steel work. So you can see we've set up, so this is a sheet of 5mm, we've just set this up to show you, you know, what it can do. And it just runs around and cuts out all the parts we need on flat planks. So using the production system we've got, we program on the orders, the schedules and what we expect to sell and what we expect to make. And then the computer system we use tells us we need to be cutting this, that or that part and so on. And from that we program the lasers to what bits we need to cut.
So this enables you to be stocking the right levels.
Yeah, so we always carry stock of parts because it's key to, you know, smoothing out demand and making sure we can always meet customer requirements. But this allows us to carry the right amount of stock, so we're not sat on miles of, you know, massive stock. We carry a lot of it, but it's that balance, trying to carry the right amount of the right parts.
Okay, and behind you you've got the well, looks a very clever piece of equipment, James.
I mean, this is part of the machine here, so this is it actually running, so it uses G codes. Then if I move this one out of the way, this is some of the equipment we use. So these are just the parts we've programmed on to cut just to demonstrate the machine. And then we've got a system here which tells us what parts it needs and, you know, where they're actually coming from, what they're doing.
I recognise some of these code names, James.
So you'll see a lot of these parts, like they'll be specific to a machine. So that's an FM120 and a part number and a description and so on. Just to try and make it easy for our guys to use it efficient.
Excellent.
So with this machine we've got two tables, so a changeover system. So with this bed that's out of the machine at the minute, you use for collecting the parts, so as they're cut you collect them off from the various sheets, so they can then go for folding or fabrication, whichever, or just to be stored, while the machine is running and cutting other parts, and then when they're done then we swap the two tables over. It also allows you to, so that we can load it, you can see behind you we've got the loading jib here, so we can quickly and easily load the steel work onto the table.
So that's a swing jib that would pick it up, James, and then bring the sheet over.
Load it onto the machine. So it just makes it efficient, safe and easy. We try and do it properly. This is just the cutting slag under here, the smaller parts, the cut out parts. You get some bits like that, that's an actual part which is falling through, which will be picked up when they clean them out. For the most part it's a very clean process, because obviously you've got extractors on it, and it's all contained within the unit itself. So the process we use here for folding the steelwork is nice and simple. Once we cut it on the laser, we bring it over to this machine. You'll see the back stops there move to adjust for what we're actually cutting. And it just forms the steel into the shapes there.
And what thickness is that piece there that we've
So
just
that's
folded?
5mm thick piece.
And what parts that fit onto?
And that goes on the axle assemblies on the flail mowers.
Okay, I'm just going to come back.
It's 160 ton tread, up to 3 metres. So it does everything we need.
Say again, it does up to?
160 tons up to 3 metres wide. Right, so the balancing process on the rotors, once they're fabricated, so this is a fully fabricated rotor, this one actually has been balanced. They bolt all the flails on, this one's on standard flails. The rotor goes on the machine here, you pull these arms across, and then you spin the rotor up to speed to measure where there's any imbalance. The machine there will pretty much tell you where it wants weights added or removed, and then you weld them on if it's a larger weight, such as this one, or a smaller weight here, until the machine can run smoothly. So the reason we do that is for the lifetime of the machine. Vibration is a real killer for anything like a flail mower. You get the rotor running smoothly, the machine will last for years and years and years. Because we do it in-house, we do it to really high grade as well.
So what level is it balanced to?
G 6.3, so it's the same as drive shafts on cars and so on. So it's pretty high spec.
And this machine over the back here, when it's switched on and being used, that's what tells you where to put the
so
balance weights?
It measures the residual imbalance, tells you where to add or remove weights to get it running smoothly. And this all comes with guarding and everything, just obviously from safety. See, it's locked out because the machine's turned off.
Brilliant. That's great, James. Thanks for that.
This is all various jigs and parts for the fixtures that we make. Depending on the part, they'll have a specific jig, or some of them are just done on the welding bench as required. Some of the bigger stuff, obviously, that you axles, and this is taken from the rotary mower for locating the parts and getting them assembled correctly and accurately, which we will produce in-house.
And over here on the shelf, James, which ones are these?
There's a whole world of jigs over here for various parts. They'll usually have
I
a
recognise that one up
somewhere.
there. That looks like a feeder jig, is it?
Yeah, that is.
Okay.
So with the welding bays we've got set up, they've all got their constant extraction systems in it to comply with regulations. A lot of the parts, the simple stuff is just done, on the benches, and we have the jigs as well for various bits of equipment. Right, so all of the fabricated products that we make here, once they come out of fabrication next door, they come through for pre-treatment before paint. So you'll find that a lot of the parts here, you get mill scale, which is a lot of oils and dirt on the machinery. So we use a shot blasting process. So you use high pressure air, and there's chilled iron grit, which is fired at the steelwork, cleans all of the dirt off to give you a nice clean surface to apply the powder to. You can find some. If we look at the machine over here, so then once you've taken that mill scale off, you get a nice roughened surface finish, so it's clean but got a good surface roughness for the paint to stick to, and that's what makes the difference to the lifetime of the product overall.
Coming in.
I'll show you. Might be the easiest way. So the short blasting process itself, this is like a rubber lined room we do it in. Because you're using high pressure air, obviously you've got breathing equipment for the guys when they're using it here. And like I say, you're firing the steel shot, which is what you see on the floor, at the steel to clean it, very high pressure and very high speeds, and that's what takes all the dirt and scale off. And then obviously with the extractors in here, it removes all the dust. to give you the finish. We use a powder applied paint system, so all of the machines are shot blasted, so that takes off all the mill scale and dirt from them, gives the paint something to stick to, and makes the lifetime of the product hugely increased. And then once we blasted them, we then put this powder applied paint on, so it sticks electrostatically, and then we cook it in an oven to get the full hardness.
So the oven's over here.
So the minute it's a batch oven that we use, so you can only fit a certain amount in at a time, but cooks the product up to 200 degrees for 20 minutes to cure the paint on there. And then once it's finished its cycle, the paint will be fully hard, with the sort of shine and finish that you'd expect. So if you look at this, this is obviously a fully cured product, and that will last decades as long as it's looked after well, because it's good quality paint and good quality preparation.
Hope you found that video informative. Please subscribe to our channel or share with any friends or colleagues, and we will send future videos out via our channel, and we hope you enjoy them. Thank you.